question here today is, what are the different types of energy? We'd already talked about what energy is, which is the ability to do work. And kinetic energy is that energy when something is moving. So whenever an object is moving, it has the ability to do work. For example, a football player that wants to tackle somebody, they're going to start moving, and as they have moving, they have the energy necessary to exert a force on another player and move that other player another distance to tackle them. So moving objects have energy. We call this energy kinetic energy. Kinetic in physics is a term that means motion. It is a scalar value, which means it has no direction. You either have the energy or you don't. It doesn't have any directional north, south, east, or west that is applied to it. It is always a positive number. You can't have a negative kinetic energy. You either have energy, kinetic energy, or you don't have kinetic energy. And we can see this in our formula. Our formula is that the kinetic energy, Ke, is equal to 1/2 the mass times the speed squared. Now, mass can never be negative. You can't have a negative amount of matter. And so that means that the kinetic energy is always positive. And the speed, being a scalar, is never negative as well. But even if it were, it is squared anyway. So when you square a number, it always becomes positive. So no matter what, the kinetic energy will always be a positive number since we're multiplying other numbers that are positive together. In order to use this formula, we want the mass to be in kilograms, we want the speed to be in meters per second, and we want the kinetic energy here to be in joules then. So all forms of energy and work are in joules. Now one thing I want to point out to you here is that the speed is squared, but the mass is not. What that means is that the kinetic energy is more dependent upon speed than it is upon mass. Let's look at an example to illustrate. Let's say we have something that has a mass of 2 kilograms. That's roughly about 4 pounds. So we might be talking about something like a dog per se. And it's moving at a speed of 4 meters per second. And we're going to calculate that kinetic energy. And remember, kinetic energy is 1/2 the mass times the speed squared. The mass is 2. And the speed is 4. And that is squared. So we get the kinetic energy when we solve for this. 1/2 of 2 is 1. 1 times 4 squared, which is 16, is 16. So we get a kinetic energy of 16 joules. Now what happens if we double the mass? Let's say we have a mass of 4 kilograms, still have the same speed of 4 meters per second. Well, now to calculate our kinetic energy, it's still 1/2 mv squared. Mass is 4. And the speed is also 4. If I calculate this, 1/2 of 4 is 2. And 4 squared is 16. So we take 2 times 16, which gets us 32 joules. And what we've done here is by doubling the mass, we have doubled the kinetic energy. We have 2 times the kinetic energy when we double the mass. But what happens if we double the speed? Let's say we again have that mass of 2 kilograms, and that object, again, size of about 4 pounds, so maybe like a smaller dog, say that it's moving at 2 meters per second. We're going to calculate that kinetic energy. Again, the mass is 2, speed is 2, but the speed is squared. And we come out with kinetic energy to be 4 joules. Now, what happens if we have that same object, that same dog, and we are going to now double the speed? You might say, well, if we double the speed, won't we have double the kinetic energy? Let's calculate and find out. So we have our formula. The mass is 2, and the speed is 4, but the speed is squared. We have 1/2 of 2, which is 1. 4 squared is 16, and 1 times 16 is 16. And so we see that we haven't doubled the kinetic energy at all. No, double would be 8. Instead, what we have done was we have quadrupled the kinetic energy. We have 4 times the kinetic energy when we double the speed. You might say, well, big deal. What's the whole application of this? And the application is, let's say you're driving in your car. If you double your speed in your car, you now have 4 times the kinetic energy. That means it's going to take 4 times as much work to stop the car. And therefore, you have to stop the car over 4 times the distance. So by doubling your speed, you now have to have 4 times the distance to stop your car. And that's what makes it so dangerous then to speed, especially in different areas that have a larger population. What we want to do next is we're going to make a calculation based on a realistic situation. We want to know what is the kinetic energy of an 1,100 kilogram car moving at 25 meters per second. So 1,100 kilograms is roughly 2,500 pounds, a little over a ton. And if it's moving at 25 meters per second, that means it's moving a little over 50 miles per hour. So we're going to be on the highway here. We start by drawing our picture. We write down our givens. The 1,100 is the mass. The 25 is our speed. And we want to find the kinetic energy. We have our formula. We put in our values. And then we multiply and solve. And it turns out we get 343,750 joules. So you can see that a car moving on the highway has a lot of energy, and therefore it's going to take a lot of work to stop that car. And again, if you double that speed, you're not going to just double the kinetic energy, double the amount of work to stop the car, you will quadruple it. If you were to triple the speed, because the speed is squared, you'd actually increase the amount of energy by a factor of 9, because 3 squared is 9. So again, the kinetic energy is more dependent upon speed than it is dependent upon mass.